In this example, let's imagine a total of 500 households that received food distribution make up the sampling frame, and we've calculated a sample size for our survey of 150 households. The strata we're interested in is rural and urban, and we've already made the designations in our sampling frame, with each household belonging to just one subgroup. We have determined we want to draw a proportionate sample representative of the divide of urban versus rural in the population. Within the population of interest, there are 10,000 households, 8,000 in rural areas, and 2,000 in urban areas. To calculate the proportionate sample size for each subgroup, we divide the number of units in each subgroup by the total population, in this case 10,000 households, and multiply by 150, our desired sample size. So to calculate the sample size for households in rural areas, we'll divide 8,000 by 10,000 and multiply the quotient by 150, the total sample size desired. We'll do the same for urban households, dividing 2,000 by 10,000 and multiplying that number by 150. You can see here that the proportionate sample size for urban will be 30 households, and the proportionate sample size for rural will be 120 households. To double check we've done this correctly, we should always sum these numbers to make sure they add up to our desired total sample size, 150. Now that we've determined the sample size for each stratum, we can use one of our random sampling strategies to select a sample from each stratum. As shown in the demo for drawing a simple random sample, we'll assign each household a random number using the rand function in Excel. You can see the formula has generated a number here in cell D2. We'll double-click the bottom right of the cell to apply this formula to all the other cells in this column. As we scroll through, we can see each household has been assigned a random number. Because there's a random number generator function in these cells, Excel will continue to randomly generate numbers whenever the spreadsheet is edited. So I'm going to copy and repaste these values so they won't change. Now we'll rank these random numbers from low to high within each of the stratum by clicking the Sort and Filter button on the Home ribbon of Excel. By going to Custom Sort, we can add different layers to sort by. So we're going to want to add 2 levels of sorting. First, we'll sort by our strata, in this case, the urban rural, column C. Then we want to sort by the random number in column D. So we'll add a level and then sort by column D. Let's first draw our sample for the rural subgroup, which will be 120 households. Because we've calculated a sample size of 120 for our rural subgroup, we'll select the first 120 households. These are the households we'll survey from our rural subgroup. Next, we'll do the same exact thing for our urban subgroup. So we'll scroll down to where the list of urban households are listed. Now we're only seeing households from our urban subgroup with an associated random number sorted from low to high. Since we've calculated a sample size of 30 households for our urban subgroup, we'll select the first 30. These are the households we'll survey for our urban subgroup. Together, the highlighted rows make up our total sample of 150 households, with 120 households from the rural areas and 30 households from urban areas. These numbers are proportionate to the division of urban versus rural households in the population. Something to note about the method of proportionate stratified sampling is that we could have achieved the same result using simple random sampling or systematic random sampling if we first sorted the units by urban versus rural. Both of these methods will produce a proportionate sample equal to the same distribution of the population. As such, the main reason we'll generally use stratified sampling is to draw equal samples from each of our strata, as we'll see in the next example.